Q&A to do today. We go out to different conferences, get a whole bunch of questions. Sometimes we get the chance to answer them, sometimes we don't. The ones we don't, I'm answering them today. Calm down there, Turbo. Okay, so this one. Ding! How are colloidal silica dispersions used with expanded shale to make a denser ICC concrete? If you don't know what ICC concrete is, or it's just ICC, it stands for internally cured concrete, where we're taking this expanded shale that can have an absorption anywhere between 5–10%, maybe more, maybe a little bit less. We're pre-soaking it with a certain amount of water so that when it's mixed into the concrete, there's water that is used for hydration later on. Stop messing with the peacock! Sorry. So water later on to enhance the interfacial zone where the hydrated cement matrix meets the aggregate. And ultimately what we get out of this is a concrete composite that has a denser matrix around that interfacial zone, which locks in the aggregate, reduces crack length, reduces permeability, increases strength, reduces shrinkage. It's pretty awesome stuff. By pre-soaking with colloidal silica, you're taking that to the next level. So what we're doing is we're adding colloidal silica into that pre-soak, same thing that we do with recycled concrete aggregate, so that we're actually putting something at that interfacial zone besides water. We're putting that reactive silica that wants to consume the calcium hydroxide to create more of that calcium silicate hydrate. So again, we're creating the same effect. We're putting something, we're pre-soaking something into that expanded shale, but now it's going to have a pozzolanic event, an instantaneous pozzolanic reaction, accelerated cement to solution, heterogeneous nucleation, all those things that we get out of that colloidal silica, but now we focus it at one of the weakest points of our concrete composite, which is that interfacial zone. And because of that, we create a concrete that is stronger and lasts longer. Thanks for joining us today. Go concrete!